All right, so on Monday, we had started looking at the exam review for chapter 2, and we're going to continue doing that. We're on problem 6. Hopefully my iPad's charge will last. For some reason, it didn't get charged up last time. All right, so create a linear model for the data in the table. So I'm going to create a linear model using my calculator. And I'm going to put X in one list, and I'm going to put Y in a second list. And then we're going to let the calculator run a linear regression on this. So I'm going to put X in L1 and Y in L2. So let me open the calculator. You kind of move things around a little bit. There we go. All right, so I'm going to go to my list, stat, edit. And I do have stuff in my list, so I'm going to clear those out. And let's see if I can't get this inputted. So I have 2, 6, 9, 10, 11, 13, and 17. So I have my X values in. Now I'm going to go to my second list and put in my Y's. All right, so now that I have my data in, I do always check to make sure I didn't make any mistakes. 5, 10, 14, 16, 18, 21, 26. All right, so now that the data is in, I'm going to get out of here. So I'm going to do a second quit, get out, and then go back in. And I'm going to go to the calculate menu, and I'm going to use number 4. Now you might notice that number 8 is also a linear regression. I'm not going to use that one just because it puts the X second, and that might be confusing. So I'm going to use number 4. Okay, and my data is in L1 and L2. I can store this equation just in case I need it. So I'm going to go to my variables menu, my Y variables, my function number 1. And that will store it in the Y1 equals, so I can graph it if I need to. Okay, then I'm going to calculate. So A is 1.4. Make sure I got this right. 1.4375 and B is 1.75. So up here in my fields in my math lab, the number that I'm multiplying times the X, it tells me right here that that is A. So that first field is going to be the 1.43. And how much do they tell me to round this to? 3 decimal places. So 1.438. And B is the constant, it's the y-intercept, that is 1.75. So I'm going to input that into my math lab. 1.438, because they told me to round it to 3 decimal places, and 1.75. All right, and that's all there is to that problem. Problem 7, the figure shows, and the figure they mean this bar chart down here that you can't see. This bar chart down here at the bottom. So it says the figure shows how monthly benefits in a country differ when the age a recipient decides to start receiving benefits. The example shown in this table is for recipients whose monthly benefit is $1,000 if benefits start being paid at a full retirement age of 66. Note that benefits do not start being paid before age 62, and that the monthly benefit does not increase if the starting age is after 70. Lots of information you don't really need to solve the problem. Complete parts A through C. Part A, can the data be modeled exactly by a linear function? Explain. To be able to be modeled exactly by a linear function, these differences, we're going each time in an increment of 1 in the age. These must, then the amount paid must be exactly the same. For it to be linear, each difference in payment must be identical. And what is that going to be? Is that 63? So since the amount paid is not exact from year to year, this cannot be modeled exactly by a linear function. Okay, so the answer is no, but you got two choices for no. No, the data do not include ages between whole numbers. But having who cares? So what's the other no? No, increases in benefit amounts from 1 year to the next are not constant. That is the reason it cannot be modeled exactly by a linear function. Can we model it by a linear function? Sure. By putting the data in our calculator, we can do that. Okay, or we're going to do it by hand. B, can the data shown from 66 to 70 be modeled exactly by a linear function? Explain. So now let's just look at 66 to 70. Okay, so 66 to 70, 66 to 70, 66 to 70, 66 to 70, 66 to 70. Okay, so what do we got? We got $90 difference here. 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 So from 66 to 70, each year, the difference in the amount of money, the benefit, is exactly 90. So the answer is yes. It can be modeled exactly from age 66 to 70. So we got two yeses, right? Yes, it's either B or C. Yes, increases in benefit amounts from year to year are to the next are constant. There you go. Yes, the increase in benefits amounts for each year is equal to the, no, it's B. All right, so write a linear function S equals f of x that models data shown from age 66 to age 70. Okay, the difference, the 90 from year to year, is the slope of your line. So each year, each 1 year, your benefit increases by $90. So that's the slope. It's 90 over 1. So my equation is S minus, and I just pick a point. So pick any point. Oh, I don't know. Pick this one. So S minus 1,000 is equal to 90 times, what are we using down there? X. X minus 66. Could you pick any of those points from 66 to 70 to use? Sure. Okay, and then just simplify. S minus 1,000 equals 90x, distribute 90 times 66. My calculator says that is 5,940. Add 1,000 to both sides. And the model would be 90x minus 4940. 90x minus 4940. Okay. Another one to model linearly. Problem 8. Disposable income is the amount left after taxes have been paid and is one measure of health of the economy. It's tough right now. The table gives the total disposable income for a country in billions of dollars for selected years from 2010 and projected to 2040. Can these data be fitted exactly by a linear model? Well, looks like we have each year, the difference is 5. So we would have to have a proportional increase in the benefits. So we would need to see these to be constant. These would need to be constant. Are they constant? 11,404 minus 10, 277. My calculator says this is 1.127, and then check the next two, 12.043 minus 11.404. My calculator says this is 0.639. So the answer is no. Since the increases in the income is not constant, this can't be modeled exactly by a linear function. So we got 2 no's. No, the data do not know. It's not it. It's got to be this one. No, the first differences are not constant for uniform inputs. Okay, so find a linear model that models data where X is the number of years after 2000. So we are going to input into our calculator the years after 2000. So we're going to input 10, 15, 20, 25, 30, 35, 40, and then these income in billions of dollars. Okay, so I'm going to open my calculator up. And for now, I think I'll just use a different list. So I think I'll use maybe L3 and L4, just because I don't want to delete what I put in there before in case I need to look at it. So I'm going to put the years since 2000 in L3. And then I'm going to put the income in L4. All right, and then I'm going to do a quick check. All right, I think I'm good. All right, so I'm going to get out of here. And then I'm going to go back into my statistics menu and I'm going to calculate the linear regression. And I'm going to calculate it on L3 and L4. So I need to put L3 and L4 in there. So I'm going to put second 3, L3, go down, second 4, that's L4. I don't have a frequency list. I'm gonna go ahead and store this just in case I need it. Oops, that's not right. I can start that over again. Better, all right. So I get that the slope is 0.30995. It's telling me to round it off to 3 decimal places. So that would be 0.310. And the y-intercept is 6.712. Okay, so we're going to put that in. .310 6.712. What does the model predict the total disposable income will be in 2028? I can certainly take this equation and plug in 28. I could certainly do that. That would be quite easy to do. Or I can let my calculator calculate that for me. And to do that, I do need to graph that line. So I'm going to hit the zoom stat. I have to have that line graphed before I can actually do any calculation with it. Okay, so let's see if I can do a calculation. So we're going to go second calc value. And what are we looking for? 2028? Is that then we're going to put in 28? I'm out of range. My window is not correct. So I'm going to change my window so that X is in there. So make that 40. If you get an error when you try to do this, it's because the value that you're trying to calculate is out of range of the window that's been set. And I must not have my stat plot on, or it would actually have done this. But anyway, I'm mumbling. 28. What are you yelling at me for? Okay, let me turn the stat bottom. Let me draw that. The reason it's not liking the stat plot not being on. So let's turn that on. All right, this is again, do a zoom stat. There we go. Now let's try it. It would have been way faster by just plunking it in there. There we go. 15.391. All right. It's like I get to do another one. The table gives the projections of the population in millions of a country's residents over 16 from 2015 to 2060. Graph the data with Y equal to the population in millions and X equal to the number of years after 2010. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So I'm going to put in, I'm going to use L5 and L6. So I'm going to use L5 to put the 5, 10, 15, 20, 25, 30, etc. in. And I'm going to use L6 to put the population in millions. Okay. All right, so let me get this out of the way. I'm going to go stat, edit, go over to L5 and L6 and start putting in the years. 5, 10, 15, 20, 25, 30, 35, 40, 45, oops, 45, 15. Okay. Then I'm going to put the millions of people to 54.161. Okay, do a quick check. Okay, looks good. All right, so I am going to graph this using a stat plot. So I'm going to go to my stat plots. And I might as well just use the one that's on, but I do need to change my X list to L5 and L6, whatever you used is fine. I'm gonna use L5 and L6, because that's where I put my data. And then I'm gonna do is, I'm gonna go to my Y equals and clear that out, by the way. Clear that out. And then I'm gonna do a zoom 9. Okay. Now they have their window set 0 to 60 by 0 to 400 with a X scale of 5 and a Y scale of 50, so I probably need to do that. So I'm gonna go to my window and change that from 0, oops. Go back up. I won't let you, I won't let me do it. I gotta put a max in, 60. Go back up. 0. It's 0 to 60 with a scale of 5. And a Y minimum of 0 and a Y max of 400 with a scale of 50. All right, now let's graph it. So which one is that? B? It's not A because it's fairly linear and A kind of does this jog up and down. So it's not A, it's got to be B. All right, B. All right, so now that I have the graph, I am going to run the regression on it. So I'm going to go to my stat menu. Calculate number 4. I'm going to do that on L5 and L6 because that is where I put my data. And I'm going to store that in Y1. It would be nice if it kept that, wouldn't it? That you didn't have to put that in every time. Okay. All right. So I get that A is 1.890 and B is 246.994. So I'm going to put that in. And then I'm going to hit the graph button. And it looks like which one? It's got to be B, correct? It's got to be B because I rejected A earlier. That is not the scatter plot, so it's got to be B. Okay, is the linear model a good fit, a very good fit, or a poor fit? You get a choice here. Well, the line goes through most of your data points, correct? So it's a very good fit. What does the model predict that the population will be in 2036? So that would be in year what? X equals 26? Is that the number of years since 2010? Is that what we did? Yep. So 2036 minus 2010 would be 26. So we're going to calculate the value when X is 26. And I get 296.136 million. In what year does the model predict the population will be 336.823? So now it wants X when Y is 336.823. Now you could certainly plug this in and solve it algebraically. Way too much work. So we're going to solve this using the intersection of these two lines. So we're going to graph in our Y equals. We're going to graph 336.823. We're going to graph that horizontal line. 336.823. Then when you hit the graph button, you see where it intersects? Intersects right there. So we're going to calculate that intersection. So does it intersect at 47.527? So what year is that? So it intersects at X equals, what did I say? 48 approximately. So what year is that? So 2010 plus 48, is that 2058? All right. Solve the system of equations graphically. By the way, I will post this to the review course today. I'll post this PDF to the review course. So you got two courses, right? It'll be in the review course. Solve the system of equations graphically. So I got a lot of stuff to clear out here. Okay, so the first thing I'm going to go do is turn my stat plots off momentarily. Turn those off. Because I don't want to graph them. And then I'm going to go to my Y equals and I'm going to clear out what I got in there. Okay, so both of those equations are solved for Y. Wasn't that nice of them? So I'm going to graph both of those lines. So I'm going to graph Y equals 2x minus 8 to x minus 8. And I'm going to graph 3x plus 10. 3x plus 10. I think it's negative 18. Let's see. And then I'm going to zoom standard. And it's intersecting somewhere down below where my window is. I said, I'm pretty sure the answer is negative 18 just by looking at the equations. But I do need to move my window down so that I can see where they intersect. Otherwise, I can't calculate it. Okay, so I'm going to go to my window and let's set the Y min. Let's set negative 30. See if we can see it. Nope, I need to change my X because it's way over here. I said X, didn't I? Let's do negative 30 in the X direction. Oops. Still can't see it. And change my window again. Let's change the Y min. Oh, let's just go crazy. Let's do negative 100. And we can change our scale to 10 to make it prettier. There we go. Now we can see it. I just had to keep changing the window so I could see where they intersect. Nothing sacred about this. I didn't write anything down on my paper, how I figured this out. Now, I probably could have looked at their window and figured it out. As a matter of fact, did they tell me the window? Well, that doesn't help me that they actually told me the window. Wasn't that nice of them to tell me the window, which I totally and completely ignored? All right, let's calculate the intersection. Second count. Intersection. Just love when they give you information that I just totally ignored. It's terrible. All right, intersects at -18, so x equals -18. And y is what, -44? So the intersection is x equals -18 and y equals -44. So it is this one, isn't it? Is it A? That's not really. And we get x is -18 and y is -44. Okay. Solve the system of equations by substitution. Well, isn't it nice that they had solved the top one for x? So to use substitution, I'm going to substitute the expression 5x plus 11 in for x in the second equation. So since they solved it for x for me, I might as well use that. So 4 times 5x plus 11 plus, it helps if you do it correctly, for y plus 11 plus 7y equals -37. I'm going to remove the parentheses so I can solve this for y. 20y plus 44 plus 7y equals -35. I'm going to combine like terms. 20y and 7y is 27y plus 44 equals -35. Subtract the 44 from both sides. 27y equals -79. Is that right? No, that's not right. I got something wrong. That's 37. I knew I had something wrong. That's a 37, folks. You know how I knew I had something wrong? I was going to get a fraction, and I know at this point they're not going to give me a fractional answer. I just knew that. So it's kind of the way my math lab works. What's 81 divided by 27? Is that -3? That's y, Lisa. Okay, then how do we calculate x? We're going to use that equation, x equals 5y plus 11. Is that -4? Problem 12, solve the following systems of equations by elimination if a solution exists. I do need to rewrite this equation here. I need to get that 5x over there, so I'm going to add it to both sides. I need to get that 15 over there, so I'm going to add it to both sides. So I need to get it in this form so I can use elimination. All right, so then what am I going to do? I don't know. What did I do? I multiplied the top equation by -5 and the bottom equation by 6. And what that'll do is it'll get -30x in the top and +30x in the bottom. And then when I add them together, it'll eliminate the x's. So I'm going to write that down here. So I have -30x, -5 times +12 is -60y, -5 times 18, I think that's -90. Then we're gonna multiply the 6 times the 5, get 30x. The 6 times the 10 is 60y, uh-oh. And the 6 times 15 is 90, uh-oh. What do that mean? Does not have a specific solution. So it either means that it has infinitely many solutions or it has no solution. Which one is it? Do you remember?
Infinite.
That is correct. If you end up with something that is true, then there are infinitely many solutions. If you end up with something that is not true, it's false, then there are no solutions. All right. A manufacturer of household items has total revenue given by the function R equals 18.5x and has total cost given by C equals 16x plus 400, where x is the number of items produced and sold. Use graphical methods. Yeah, it's too much work. That will do it. Use graphical methods to find the number of units at which the manufacturer will break even. It breaks even when R equals C. And do I care? Stop helping me. The iPad gets static and it starts doing weird things. This is what you would have to solve. And that's really easy to solve. So do I care if you solve it algebraically? No. So what is x? X is 160. I'll go ahead and solve it graphically just because they tell me to. Okay, so we're going to graph both revenue and cost. Do they give me a window to graph it in? I might follow the instructions this time. Nope. I guess I get to guess. Okay, so we're going to graph 18x and 16x plus 400. So 18.5x, 14.5x, and 16x plus 400. Oops, lost my calculator. So the revenue function is going to start at 0, 0, when x is 0, y is 0, and go up. The cost function is going to start at 400 and go up. So I probably need to at least adjust my window somewhere, greater than 400. So let's see. I'm going to make my window. Actually, I know what the answer is. It's 160, isn't it? So I'm going to make my window 0 to 200 with a scale of 10, and maybe 0 to, I don't know, let's do 1,000. That's 10,000. Delete. And let's maybe do a scale of 100. I don't know. Okay, so it's definitely above my window. So let's change that y to, let's do 10,000. What does it hurt? And maybe do a scale of 1,000. That's better. So I can see the intersection out here somewhere. So I can calculate that. So it intersects at 160, which is what I found by solving it algebraically. All right, problem 14. Gonna need the calculator again, I think, maybe. No, they're gonna have us solve it graphically, algebraically. The demand for a certain product is given by P plus 2Q equals 366. And the supply for this product is given by P minus 4Q equals 168, where P is the price and Q is the number of products. Complete parts A and B. Find the price at which the quantity demanded equals the quantity supplied. So we have the demand equation is this P plus 2Q equals 366, and the supply equation is the P minus 4Q equals 168. Find the price at which the quantity demanded equals the quantity supplied. So you want to find the P, where these two things are the same, and then you want to find the Q, where these two things are the same. So price is P, quantity is Q. Isn't that nice they use P and Q? So we want to find the solution to this system of equations. What did I do? I multiplied equation 1, the demand equation, by 2 and added it to the supply. You could certainly multiply that equation by -1 and add it to the supply. You could do that. That would work too. I like to keep things positive. So I'm going to multiply by 2. 366 divided by 2 is 732. And then I'm going to add that to the supply equation. What time is it? So I get 3P is 900. Divide by 3, so P is 300. So the price where I have equilibrium is at 300. To find the quantity where I have equilibrium, I need to find Q. So I'm going to plug this back into the first equation. I'm going to plug that in right there. So Q is 33. So the equilibrium price is 300. The quantity is 33. All right. Did I leave myself enough room to solve this silly equation, this inequality? Solve the inequality both algebraically and graphically. I'm just going to solve it algebraically and then graph it. I am not going to solve it algebraically, too much work. Graphically, too much work. Then draw a number line. Once I get it solved algebraically, then I don't really need to solve it graphically. So I'm going to probably see if I can do this right in here. So I'm going to distribute the 4 across. So I get 16x minus 12 is less than or equal to 5x minus 20. I'm going to move the 5x over. Add the 12 to both sides. Divide both sides by 11. 16x minus 12. Oh, I lost my 5x minus 5x. That's right. I lost my minus in front of my 20, folks. That is a -20. -20 plus 12 is -8. So x is less than or equal to -8/11. So you're gonna type in x is less than or equal to -8/11. And you will have in your toolbar the less than or equal to symbol available. So in interval notation, what is that? That's everything to the left of -8/11. But we're gonna use a bracket because we have equals. So which graph is that? Is it D? It's got a point to the left. So it's between D and E and G. But E and G both start at a positive value. And we're starting at a negative, so it has to be D. By the process of elimination, it has to be D. I got 3 minutes to do 2 problems. Solve the double inequality. Okay, I'm gonna add 8. Whatever I add to the middle, I have to add to each end. 30. Divide by 5. So x is greater than or equal to 27/5 and it's less than 6. 27/5 here and 6 here. 17, solve the double inequality. 2x plus 9 is greater than or equal to 24 and 2x plus 9 is less than or equal to 31. So 2x plus 9 is between 31 and 24. If it's greater than 24 and it's less than 31, it's between. So subtract the 9. Is that 13? So this might be a good time since I've got 1 minute left. So this is 15 halves. And 22 divided by 2 is 11. To talk about double inequalities, this is a mistake I see people make when they're way too far along in their mathematical career to make this. That number there, the 15 halves, has to be less than 11. No matter what's in between. The way this inequality works, it says that x is bigger than 15 halves and it's less than 11. So the number on the left in this double inequality better be less than the number to the right, or this doesn't work at all. So it has to, and that's a good way of checking to see if you did this correctly. If that number is bigger, then you got something going on that's weird. All right, any questions? All right, so I did not get to